Hello everyone, welcome back to another video at Tech Tricks and Fundamentals, and today we'll be learning about arrays in C. Before we get started, make sure to like and subscribe to the channel. Right. Okay, so what is an array? So arrays are used as tables to store similar data into one variable instead of multiple other variables. So for example, over here, one way of doing this can be character A, B, C, D, E, and then defining it A, B, C, D, E every single time. Or you can just store them in an array and then define A, B, C, D into one variable, which is called letters, which is an array. And then that would go on to look something like this, where letters of 0 would be this, letters of 1 would be B, and like that. And if we specify a certain place, then it'll go into that place and leave the other places empty. So it's just there to fix repetition and help you out. So we can also use arrays to replace strings, which are basically words we use that the computer doesn't know as a function. Okay, so now that we know what arrays are, let's learn how to define and declare an array to later use. So arrays are made by adding square brackets at the end of your normal variable declaration. Your variable type also decides your array type, whether it's integer, character, double, float, or etc. So this is how you do it. So you would take an integer, numbers, this is your normal variable declaration. You would add the brackets, and then you'd add the array length, which is 6. And then after that, you'll add the values. So this is goes into a 0, 1, 2, 3, 4. And then the last value will just be 0, because these are only 5, and then we need the sixth one. So the computer auto defines it to be 0. And then again, we can see another example, which is our variable declaration, which is letters, character, and then our array length can be left blank. And then over here, we declare values. So this length automatically becomes 7 values. It becomes 1, 2, 3, 4, 5, 6, and then the end character, which we'll learn about later. So this automatically becomes 7. You don't have to do 6, but this is helpful because if you know you're later going to add an integer or a number to your array, then you can have extra space. This way, it'll be hard to, and then you'll have to do other methods. Okay. So after you define the array, we must also declare and assign values to the empty places in the array. This is done by setting a value equal to the specific slot in the variable, which is picked by selecting the slot and putting that number in square brackets, as we saw before. So over here, if we were to do integer numbers 5, which is how we declare our array, it'll create a table like this, which is titled integer with 0, 1, 2, 3, 4. Because in computers, numbers start with 0 instead of 1. So this is our first, second, third, fourth, fifth, 5 slots. And then when we do numbers of 1 is 13, then it goes into the first slot, which is the slot that is declared by the number 1 and stores 13 in it. If we do numbers 3 is 78, then in the place of 3, it'll store 78. Finally, we must also know how to print out the array values. This is done by using a for loop. We run the loop every letter in the array, and then we print out the value at that index. So for example, over here you can see our integer number 6, 1, 2, 3, 4, 5, and then our end of line character, which we'll learn about later. So over here, you would declare a for loop. You'd say integer I, this is all we learned before, where I starts at 0, I is less than 6, so it runs 5 times, and then I adds 1 every single time. And then after that, you would want to do print f, your normal print statement, and then over here, since these are all integers, you want to do %i, and then at the end you want to do numbers bracket I. So as it runs the 0th letter, so let's say print numbers of 0, which is 1, and then it'll go again and it'll print numbers of 1, which is 2, numbers of 2, which is 3, and so on. So to demonstrate this, we'll be making a program that calculates our first 15 Fibonacci numbers. For those of you who do not know what Fibonacci numbers are, they are the sum of two numbers that come before. So let's jump into it. What we want to do is we want to delete all this, and then we want to start from the top. Okay, so this is what our program looks like, and now let's run it to see what we get. So when we click run, we get a list of all our Fibonacci numbers. And to test, so it starts off at 0, it goes to 1, 1 plus 0, 1, 1 plus 1, 2, 2 plus 1, 3, and so on and so forth. Okay, so what we did here. So normally we did our include stdio, standard input output. Then inside our main function, we define array, which is called Fibonacci, which is the length 15, and it's integer type. So then we declare our first one and our Fibonacci 0 and Fibonacci 1, since the computer doesn't know that. And this is what we see here. And then we start adding them up. So we do Fibonacci, since we start this at 2, it'll say Fibonacci 2 is equal to Fibonacci 0 plus Fibonacci 1. And then 0 is 0, and this is 1. So then it goes to Fibonacci 2 is equal to 1. And then it goes Fibonacci 3 is equal to Fibonacci 1 plus Fibonacci 2, which is 1 plus 1, which is 2, and so forth until I is less than 15, so I is 14. And then after we have all the calculations, and then we store it into our Fibonacci I. So it'll go, first one will go into Fibonacci 2, Fibonacci 3, and so forth into an array. And then after we're done, we use a for loop to print out all the Fibonacci numbers. So we do integer from 0, since we want from starting, and then we print out all the way until 15. And then we have our normal for loop format, and then we do printf and the integer I, percent %i, and then the Fibonacci I format. And then after that, we return 0. As mentioned earlier, we can also use arrays to write strings. There is no data type for strings in C, unlike all the other languages like Python and Java, so we are forced to use arrays. This is done by separating our word into letters and then storing it in separate indices. So this is how it works. So you take our character word, which is our array declaration, and then we want to put in the letters of the word separated. So if you want to put in hello, we would write HELLO, and then of course our exclamation mark. And last but not least, we'll also be discussing multi-dimensional arrays. So these are proper tables which can store data within data. Or here, we can declare this by using 2 square brackets for the first rows and then the second 4 columns. So over here, we can declare by this format. So our first one is for rows, and then our second one is for columns. So when we do integer table 1, which is our variable name, and then 4 by 5 array, and then we're going to store 0 in every single one. So this is what it makes, 4 by 5, and it stores 0 in every single slot of the table. So this is really helpful when you're working with a lot of data, and we'll look at an example now. So let's assume now that we are a student and we're making a transcript. So we want to store data from our 2 semesters for 6 classes. You probably would declare 6 different arrays and then add the 2 semester grades to each array. But instead, we can use a multi-dimensional array instead to store it on all in one variable. All right, so let's take a look at it. So let's delete this from our last program. And we're going to just and this is how we would declare our multi-dimensional array. So in here, what we do is we declare transcript, and then we tell it we want 6 by 2. So we want to have 6 rows and 2 columns. So the way it's done, and then after that, we want to open our main parentheses or braces or curly brackets. And then inside that, we want to declare separate twos in forms of twos. We want to declare 6 separate values. So over here, we have 98, 98, 27, 89, 93, 89, 60, 73, 100, 100, and 91, 92. So instead of doing it 6 times where you declare transcript 1 is 98, 92, this in an array, we can put it all inside an array and declare it like this. And of course, since these are separate blocks, we won't always want to separate these by comma. And you wouldn't put a comma at the end of this one because it's the last one. And we want to have this. Normally, we don't have this at the end, as you can see over here. We want to have this because all of this is just defining this transcript right here. Or here, we're not defining the main, we're opening a main function, but this is just used to define it, as you would use, for example, for loop, and then you'd put in stuff like this. This is opening a function, so you wouldn't need these. All right, and that wraps up today's videos. Hope you guys learned something, and make sure to like and subscribe, and see you guys next time.